Hi guys, it's good to be back. Right rudder, left stick. It's been a while since I released the build guide for the open source Very Big Stick Mark II project, but I'm back and here is the electrical guide about how to hook this guy up. Sorry for taking a little while. It's a lot of craziness going on in my personal life. The biggest barrier has been space. I've recently moved into this temporary space here, which has allowed me to start working again, and that's why I've been able to make a lot of progress. And now we have the necessary breakout boards for hooking up the electrical system to make this stick work. I'd like to give a big shout out to my Patreon backers. Without you guys, it wouldn't have been possible to get this far, and I'm excited to continue working on the project. You know, just reaching the milestone of having this guy ready to hook up with simulators is very big, especially for people in the community who don't want to have to build their own control boards. But what I'm really excited is what I've got planned for the future. Just give you a little sneak peek. I've got this guy, which is future plans. I've also got some long-term plans to kind of finish the other half of my namesake. So rudder pedals are coming in the future, but stay tuned for that. Right now, we're going to focus on building the control board necessary to make this mechanical gimbal work with the computer. Now, there are two approaches to it, supporting FreeJoy and MMJoy plus Arduino. And for this video, we're going to focus on Arduino since I think it's more accessible to most people. But there are other ways to set up the project that don't need to follow this guide at all. And if you want to approach it that way, that's perfectly fine. It's an open source project, so if you want to fork it, remix it, go right ahead, post it in the community. I'd love to see it. If you'd like to support the project, check out my Patreon at patreon.com/rightrudderleftstick. There's exclusive content there, such as preview files, Fusion project files, exclusive add-ons for the project. And really, it's a really great resource for people who are building this project. If you are interested in checking it out, I've got multiple tiers. And if you happen to be of a spiral dive tier, you not only get recognized on the files themselves for the STL of the gimbal, but also on the back of the circuit board for the breakout board that we're going to be working with today. So let's get started. Hi everybody, very excited that we've got a wonderful package delivered by our wonderful sponsors, PCBway. For the electrical plans of the project, I want to be able to have a simple breakout PCB that can make it very easy for people to assemble the stick. You can solder everything directly, but that can become a little bit complicated if this is your first soldering project. So now we're going to have these ready-made PCBs, which will be available in the open source files, and also some other goodies. So let's see what they sent. Oh, they sent some swag. So we've got, let's see, nice little storage case. Oh, little PCBway logo. I think this is, I think this might actually be printed. I don't see any mold line, like any flashing. Oh, so maybe this was printed. I'm not sure. This is actually really nice and useful. It is PCBway offers this. I think you can buy it, but I think they also send it if you have an order of a certain size. I'm not sure. Don't quote me on that. But it's a ruler that has both metric and imperial. That's an actual printed PCB. Also has some references for different surface mount components. So yeah, very useful. Comes in 2 colors. That's really cool. Thanks, PCBway. We've got 2 things. This we're going to get to later. But this is our first order. We ordered 5 of them just so I have some to test with in case I mess up. But yeah, here is the Breakout PCB. These boards are designed to work both with Arduino Micro or with the Blue Pill, the SMT32C, I can't remember off the top of my head. But basically the idea is that this works with FreeJoy, and this works with MMJoy or Arduino joystick library. So you can use this breakout board with either board, especially since that the Blue Pills, as I know, and actually you can see on this one, are very tricky to find non-counterfeits. And the thing about how FreeJoy was programmed, which is an excellent open source joystick library for this board, is that in order to make all the features fit on this microprocessor, if there's any deviations in a clone, it has problems. So it can be very tricky to find a genuine blue pill, or a blue pill that works correctly with FreeJoy. So if you're going to order it with FreeJoy, just make sure you buy it from a place that has a good return policy, or pre-test the boards to make sure that they're genuine. Or Arduino also is an option. A little bit less flexibility in the Arduino, so simply the amount of I/O and other things like that. But for our purposes, if you're just building the standard configuration, both work fine. Either, you can see the layout, it's either the the blue pill or the Arduino, and you'd use the standoffs, which I don't have any on hand right now, but to either socket them with the pin headers here into the sockets, or you could solder it directly. The other thing here is that if you have an existing Thrustmaster compatible extension stick, this footprint here is actually for, if I can find the correct orientation. Yeah, see, this is why I have to test these boards. I think this is the wrong DIN connector for the ones that I have. But for testing, I can still test with soldering directly to the pins, but the intention is that by ordering this mini DIN connector, if it was the right footprint, it would just mount right there, and then you can use a Thrustmaster extension cable directly into the board, or the same pins are down here, and then you can wire directly to a shift register, a CD4021 shift register, which is the kind that Thrustmaster sticks use. TLE 5011 sensors, which are the standard design. You can actually buy in a kit, come with these guys, and that is what is used for recording the yaw and pitch axis, and that solders in on either side here. So those can also be headers with DuPont connectors, or you can solder directly to the board. But yeah, so this is what the revision 1 of the boards are going to be. And then the way that these guys are going to mount is actually right here. So there's the holes for putting 3M standoffs. In the way that these sensors mount, so I grab that, they have a spacer. The magnet that it comes with in the kit goes there. Then that sits right there on top, and that's how the sensor mounts. And then there are these M3 by, I think, 6 standoffs. And these standoffs then screw in here. Right? I'm not going to mount them in there with one hand right now, but and then the board sits right there. You would mount the sensor and magnet on that guy, run the cables here, mount the sensor and magnet on that guy, mount the PCB here with the Arduino or Blue Pill, and then run cables into the Thrustmaster connector, whether mounting this guy directly or using an extension cable, or if you're building your own grip, wiring directly into the shift register. Another thing about the flexibility is that I also have, with these pins, I have an analog axis and 2 buttons available. And now what this is for, somebody wanted to hardwire a Spitfire grip. Now this is the Authenticate design. So this is available from Authenticate, and it has its own wiring diagram, but you could hook up 2 buttons and an analog axis, and then have a spade grip wired directly in without a shift register. It's just a nice to have. And the other thing too is that this brake axis could be added. So, you know, I'm going to work on an additional file where you can add a brake axis to any other grip, and then those would wire into the auxiliary analog input, and then 2 extra buttons if you wanted to add a, let's say, something like a paddle switch. So yeah, so that's the base design of the PCB. This is revision 1. I'm probably going to have to do another revision, but I will start building and testing with these guys, do another revision, and then make those files available in the plans so people can start building. You can see the shift register identification of what each one of these pin headers are supposed to be, but if you flip on the back, one, you can see our excellent Patreon backers. If you're interested in getting early release versions of the files, please check out the Patreon. But you can also see the identification of what all of these pins correspond to for wiring directly. These are actually mirrored of each other. So data, these are the same pins located in two different spaces. This is intended to be for using a surface mounted mini DIN connector so that you can use a TN extension cable, or wiring directly in if you were making your own cable, or if you were modifying a PS2 keyboard cable, you could wire it directly into there. And then here's the identification for the other parts. On these guys, it just identifies VCC and ground here. And then you can see at the face here, this is where the headers, or not the headers, the socket for the Arduino goes, and these are the rows for the blue pill. Another important point is that it is very challenging to find blue pills that aren't knockoffs. So I've got these guys here, and these guys work kind of okay. They start acting up whenever I use things with shift registers. These guys with the dual connectors here. If you're making a button box, these ones seem to work okay with FreeJoy, but anything that involves clock signals or chip select, it just starts having a panic attack. So, garbage.
Endless trash!
The other one I've got are these guys that I found on AliExpress called the WeAct Studio, which I think is actually some advanced modification of the blue pill specification. And the way to identify them is they have Type-C connectors. They seem to work, but I can't promise anything. So it's really tough to find genuine blue pills anymore where this chip is not a knockoff. The problem is that because of how FreeJoy was programmed in order to fit all of the features onto that microcontroller, it makes it very sensitive to any sort of deviation to how the chip is running. So if there's any deficiencies or strange behaviors of the SMT32, FreeJoy just craps its pants. And just, it's unfortunate, that's just how it is. The only way going forward is to move FreeJoy onto a different sort of development board, and that's a long-term project. So that's why the Breakout board is also going to design for the Pro Micro Arduino. And these are easy to get, a little bit more expensive, but not by much. Less I/O, but for what we're doing, which is to hook up the SPI sensors and the shift register, it's more than enough. An important note about using one or the other is that there's actually, if I can get it in frame, there's actually a solder bridge. So you need to bridge this connection. That's why this one's marked with A, because this is going to be for the Arduino. You need to bridge this connection because the blue pill has separate clock signals. I believe it's clock signals for the sensors, the SPI sensors, and the shift register. Whereas the Arduino has to use the same clock signal for the shift register and the SPI devices. So you have to bridge this connector with a little bit of solder to convert this board to work with Arduino. That's a very important note. A lot of times these blue pill boards, and especially the Arduino boards, do not come with their headers soldered on. So what I like to do to get this started is I will get it mounted in a way that it kind of just sit at an angle, and then I will start with that pin in the corner there. And just get a little bit of heat the pad. It's hard for me to do this and look at the monitor, so let me just focus on there. There we go. Okay. So that one's in. Right? Now I will make sure this is nice and straight. Make sure that's in there straight. And now I will look at the part instead of at the monitor. What I'll do is when I have the one on, I will then use something that I use as a reference, so like this guy, kind of stick it on there, and use that to make sure that my other row goes in straight. I'll do that again, doing the two ends. So I have it mounted in there, I get it in there, nice. And then yeah, and you take that out, and there you go. You've got your ready to go microcontroller module. And then we'll repeat that with Arduino. The Arduino cannot use the USB connector because it doesn't have the pins on the socket. But in order to configure this for Arduino, we have to bridge this connection to combine two pins that are separate on the BlueJoy. This is fairly easy to do. You just kind of go heat up the pad, put a little bit of solder on it. Now, those two traces are connected to each other. We need to put in our pin headers, right? These guys. So the way to do that, I actually find is easier. You take our Arduino that's already been done, take the pin, that's the one that you're not, the last one, like the one beyond you're using, pull it out. There you go. Now you can see which one you're cutting, and you also now don't have to cut through metal. Then you just use some flush cutters. So now we have two of these guys. We can stick them on to the board where they're gonna go, right? And then let's just angle it ever so slightly so gravity holds it in place, and then just try and solder in a couple of corners. There we go. And then we can see this is ground back here, right? And oh, this one doesn't have it labeled, but you'd want to make sure that the ground matches, but the USB port should be pointing up. Right, same with that one, points up. And then there you go. Now we have a Pro Micro socketed into the board. Now, at this stage, we would socket in this guy too if I hadn't downloaded the wrong data sheet and have the wrong pin configuration for this guy. So in a future revision, it would connect there, and that would allow you to plug in directly into it. Somehow the data sheet, even though this is the part from DigiKey and I downloaded the data sheet from DigiKey, it's wrong. So thanks, DigiKey. PCBway also sent me this part that is 3D printed in glass fiber nylon. Now, the intention for the gimbal is for it to be built out of something sturdy like PETG because of the loads that are being put onto these components, the cams. Theoretically, you would be able to print everything else about the gimbal out of something like PLA+, and that would be more than sufficient for holding the forces necessary in the stick, except for these parts, because these parts are what load with the spring and what the cam rides on. You can see that these are the cam surfaces that run against the spring. So these have huge amounts of sustained load. And if you print this in PLA+, it will creep. The plastic will distort over time from the sustained load. PETG, ABS, ASA, all those things can handle the sustained load. PLA+ cannot. The rest of the gimbal, you could build out of PLA+, but as an option, you could then go to somewhere like PCBway and have these cams printed in PETG, or in the case of this, very, very, very tough and durable glass fiber nylon. So this is an entire set of cams printed entirely in glass fiber nylon. So this is very, very durable stuff. And this would be the idea that you could print these components and maybe a couple of other core components such as the rollers, but I think you might be able to get away with PLA+ for those. But print these components out of a durable material by PCBway, and then you can print the entire gimbal on your printer that might have only the capability of printing PLA and cooler temperature materials. And the holes have been redesigned so that the tolerances for the bearings, they have these little gripper things, so the bearings can now just easily friction fit. You don't have to hammer them in anymore. It's just a slight bevel, so they go in easy, and then you can just kind of squish them in there, and it grabs very nicely. And these are actually really nice. I'm probably going to put these guys in the prototype gimbal or in my regular flying gimbal, because this is actually really nice. The surface is pretty good. I mean, it's definitely rough to the touch because this is sintered like nylon, like it's done in the powder form. So it's not perfect, like it's not glassy smooth, but I think ultimately it doesn't really need to be. Like it's smooth enough, and in the rolling of the break-in period of using the cams, it'll work itself in and it'll be nice and smooth generally. So yeah, so definitely big thank you to PCBway for providing us these wonderful parts and these wonderful PCBs. Now, there have been some changes to the design since the original file release, but nothing too substantial that would make anything incompatible. There's some changes to this piece, like this guy has holes that have been added here for a future upgrade. Take my little nylon hole here, and let's just, oh yeah, it goes in very nicely. It's stiff, but goes in. Oh yeah. There we go. Bottom it out. That's good. There are a second set of springs here for adding an additional spring, or like a light spring if you want to have a really light stick for, let's say, helicopters, or you just you want to have basically no spring force, but you just need something to counteract the weight of the stick. You can put really weak springs on the face here, like across these two. But the threads in the printed nylon are actually great. Like I can hand tighten it, but it's not too loose. Like it's going to stay. And if you really wanted to go crazy, you could probably put some glue or something, or Loctite. But yeah, very impressed with the printing job from PCBway. And these files that are printed are obviously different because they have the tolerance holes where it kind of slots the bearing in, like a compliance hole, I guess is what they're called. Whereas this was just a straight socket that if it wasn't perfect, or there's a little bit of elephant footing, you had to hammer it in there. Now you don't. But these files are the same now. So the cams for ABS or PETG or ASA are the same ones with the compliant holes, and the exact same file can be sent to PCBway for them to print it. Let's add an extra spring. So these holes here are M4, and much of the design I try and use similar screw sizes, so these should work with M4 by 20. That should give you enough grip and still enough space to grab the spring. But yeah, these threads are excellent. I mean, you can never say how much durability printed threads have over time, but if you're only screwing it in once or twice, I think it's perfectly fine for the life of the part. So we got our spring on there. There we go. And now, oh yeah, that's great. That's really good. Yeah, that feels great. And the rough surface of the sintered, I think it's SLS process, it's not a factor because the diameter of this roller and the overall size and forces involved, you don't really feel the rough surface. And if you're printing like a small desktop joystick using this cam design that has like a cam that's this big, yes, at this size, the roughness of the surface would be a factor, but just compare a desktop cam size to this cam size, it doesn't make a difference. And the durability of this part, like I can just, like it is tough. This is indestructible stuff. So thanks again to PCBway. I really recommend if you have the means to upgrade to a more durable part for these cams, because they'll last forever. Especially if you can't print in PETG, or you can't print very large in PETG or ABS or ASA. This printed nylon stuff is a really great option, and the cost isn't too high either. I don't remember off the top of my head what the exchange rate, but I think these were just over $10 a piece to print. It might have been 15, but that's very reasonable for what you're making. So I definitely recommend PCBway service for this. So these are sensors that mount, they come pre-mounted on these PCBs, and they have wiring, and they actually come in a kit. So we've got this. Also comes with these small magnets. Now the thing about these magnets is they're actually separated on this axis. So they're not north-south here, they're north-south this way. Also got some wiring that these guys connect to. And it comes typically on AliExpress, the ones I've ordered, always comes in packs of 2. But the other thing is they come with standoffs. Now, you're intended to use the standoffs with the sensor, but I have actually got these 3D printed sockets that will hold it centered over the axis, and these standoffs we'll actually use for mounting our PCB breakout board. Actually, here's a funny thing. An M6 socket head is actually exactly, not exactly, but it's close enough that you can use this socket headed bolt. Let me get a longer one. An M6. You can actually use that. There. 4 guys there. Now we need the magnet, and we need to detect which way is north. Get that in there like that. Push it in. A little bit of glue doesn't hurt. There you go. M3 by 8. Second. And then with that, you can use the screws that the sensor kit came with. We're just going to mount it there for now. We'll adjust it later because we still have to put the wires in. There we go. Now we have the board and the sensor. Cable that comes in the kit will fit there, and then the other ends will go to, well, it doesn't matter which one is which because we can change it in software, but that'll go there. Okay, so we have the same thing there. Get that right in there. There. That's in there pretty good. You know, something to keep it in there. And put it in that way. Start with one. Get it most of the way. Very nice. And then we've got our other sensor cable. Actually, we'll want to feed it through the hole we've covered up. Get it there. Use our pliers from earlier. Yank it through. Okay, and then we've got our 2 leads. So now we need to solder these guys to these pins and these pins. Now if you look, you can see how this one's upside down. Labels are on the sensor PCBs, identifying what goes where. Now, it's not super helpful right now because the labels are on the back of this PCB, but if we remove these screws on the back, you can see what these guys are supposed to plug into. The PCB from AliExpress of the sensor board has its naming conventions, and then FreeJoy and Arduino call it something different. So on the screen now you can see what colors should go to which labels on the PCB. Before we move on to adding anything else, let's flash the Arduino with MMJoy 2 and verify that everything's working before we proceed. It's always important to do this stuff in stages. Now there's a particular version of MMJoy that we're going to use. The project has been stopped, but if you go to this website, you can download the 2016 Update 1, and that's the version that we're going to be working with. In order to enter the bootloader mode with this guy, you have to short the reset pin, RST, to the ground that's right next to it for like a second and then disconnect it. And then it'll be able to flash the firmware. Now the way to have this set up is we want to make sure that we've got our firmware pre-selected in MMJoy 2 interface. We've got the chip selected, which is the Mega 32U4, just like the firmware. We've got an Arduino chip, and we say auto start upload firmware when COM port is active. Because when we short the pin and release it, it'll activate the COM port, and then it should just go. So we plug it in, and then I short it, unshort it. And there it goes. Connect to the programmer, and we're flashing. There we go. Now our Arduino is ready to start being programmed using MMJoy 2. If we go here, we can see it shows up as MMJ-reset. Now some important housekeeping. First order of business is we're going to want to change these numbers to something unique. So I go like 1968. All right, just some number so that we're not conflicting, because these are basically the serial, like the IDs that Windows uses to identify which USB device is which. We want to make sure we have a unique number. Now we're going to name this the open source underscore very big stick underscore Mark II, and then we're going to call it ARD for Arduino to identify this as being the Arduino one. Okay, now we're going to go to Save Sets to Device. Now that puts our configuration onto the Arduino. And if we go to USB game controllers, you can see it right there. Now it doesn't have any buttons, so if you try and look at it, it fucks up. But that's great. So now that we have that working, let's disconnect this. Let's put it into our grip. So USB port up. Make sure the pins are lined up. We've got a socket into there, and we can tell that it's socketed in the right pins. We don't want it to be offset, we don't want it to be hanging at an angle, because that can cause huge problems. So we want to make sure it's nice and centered. We've got it on there. The sensors are hooked up. So to connect to a Thrustmaster grip or a Verpil grip, you need to use a 5-pin mini DIN connector. These wires have to connect to these wires here, which are labeled across the back or here. These are the same pins, so if you wanted to have a mini DIN mounted directly, it would go here, though this is revision 1, and these pins need to be changed to the wrong layout. But for now, we can connect with this. Here's the example of the connection for the Thrustmaster grip. It has this cross section which aligns to that keyway, and that's what threads on, if it'll focus. And then there you can see connector here. Now this can be open for having a cable that you can poke through there. You can modify a PS2 keyboard cable, or you can purchase from DigiKey or AliExpress the actual 5-pin DIN, mini DIN connector. We can see there's a little keyway there, And then there's this little printed insert. Little ridge there, which corresponds to that little line there. Then you put that through, push it in, line up that keyway to that keyway. That pushes into there. You can use a little bit of glue, but for now we're not. And that mounts perfectly. Right? Now you can solder the connections in there. And that's how we connect to Thrustmaster or Virpil grips. Now for cable, what you need is you need 5 connectors in the wire. This is actually cut off of an old, probably a CH or maybe a Thrustmaster like game port, vintage Windows 98 joystick. And the reason why I like that is that the wire is very flexible, it's very pliable. It's designed for abuse. Say maybe a meter of it should be enough. And we will snip the end off. Now it's important to keep track of what colors you use. So here we go. Now we're going to pick our colors. You can actually follow the guide online about what the actual Thrustmaster wire colors are. Oh, this one's actually a really good wire. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 conductors. So this is actually a really good wire. And we're going to use the colors that Thrustmaster uses since they're available in our options, which will make things much easier to follow. The other important thing, because this will mess you up before, is just remember when you solder both ends to have it going through here, because this guy doesn't fit in this way. It only comes in through the top. Which color corresponds to which guy. And it's hard to mess up because even if you're looking at it this way or this way, there's 2 and there's 3. So as long as these are mirrored to each other, you'll be okay. I'm actually going to put this on the wire. There we go. I'm gonna take this, before we forget, we run it through here. Okay, got that through there, got that through there. Make sure that key's there. For now, we're just gonna, even though this is much too short, just gonna stick it on anyway, just so that it's there. Now, I have on this grip, or on this base, I have a limiter. So if I take this limiter off, by removing these 4 M5 bolts, if you're using the stick this low, then you want the full travel. You can take it right to the end stops. All right? This is only 20 degrees, and it's printed there. So it's 10 degrees forward and back. And it has a little slot for the strain relief of the cable. Now, so for now, I'm just going to put it there, right? And then we have enough length to go in, and that's just going to tuck in into the gimbal here. And it's important it goes on the side without the cams, because if it's the side with the cams, with the roller here, there, it's going to snag the cable. You can use a little bit of tape. All right, I don't want to put heat shrink on this side because I might trim this cable in the future, and it's just it's annoying, and it's the area will like the heat shrink is permanent. With tape, I can peel it back off if I change the length of the cable, and I can reuse the part that I snip off. So I'm just going to tape that up. Some electrical tape. There you go. Now it'll be easier to get through that hole. There we go. That comes through there. And there we go. That's our cable. That's our stick. And then if we come to this guy, you can see that this cable was actually pulled out from before because I was adjusting something. So let's just run that back in and put that onto our sensor there. And in fact, now that all this is done, we can put this plate back on. So, if I remember correctly, we needed the red, orange, yellow, brown, and green. Go. We've got all of our primary wires all connected, and let's stick them back on there. Let's stick that guy, make sure front to back. There we go. And let's go back to the computer. Okay, so now that we have the wiring attached for the two sensors and the wiring attached for the shift register, we can now hook it up to the computer with our USB cable. And if we go to mmjoy here, we'll see the Arduino in the list of USB devices. Now this one we've already flashed, but the one that you flashed, if it doesn't have a configuration loaded onto it yet, will be called mmj reset like it was before. So then what you'll do is you'll download from the GitHub the necessary .mmjoy file, which is the configuration file for this version of mmjoy. Here it's called OS Very Big Stick Mark II ARD for Arduino revision 1. So this is the file. We click it and select it and make sure that the icon is blue. And if it's not blue, just click on the device again on the list. And then you have load sets from file, and then you go save sets to device, which will load this configuration onto our Arduino. And that'll write the configuration onto the Arduino using the presetup.mmjoy file. With this configuration set up, we have the sensors already hooked up and defined, and we have the shift register pins already hooked up and defined with the preset button inputs already configured. And now if I press the buttons, you can see inputs are working, and they're already pre-assigned on the side here. See that? So they should all be pre-populated. So it's only been tested with the Warthog grip, but everything should be configured. I believe it should be compatible with the F-14 and with the Virpil grips. So that's all correct. The one thing that will be different is how your sensors are set up. So the way they're configured now, it should be X and Y should be correct. But if you have your wiring backwards or whatever, it's not a big deal. You can change which axis these are assigned to. I have an inversion on one of them because sometimes you might have to mount the sensor PCB upside down if it's rolling over for whatever reason. Like you might have to tweak them. But the important thing that will be unique for every different setup is that you'll have to calibrate it specifically for your mechanical configuration. It depends on the orientation of your magnet, Depends on exactly how the PCB is centered on it. So you have to do the calibration. And you have saved with center is what you want. You can do auto, but auto means that you have to move the stick full range every time that you reconnect it. So it's better to have saved with center. You can go to calibration helper, clear data. Now while the stick is centered, and you want to do the center position when the stick is fully assembled. So this is only a short stick instead of the full extension. So I would recalibrate this once I put the full extension on just to know where the stick sits neutrally. For now, we'll say that. Clear data, set sensor, and now, while this window's open, move the stick to all of its ranges, and basically what happens is this will read what the max and min values are with it, what the travel was, and you say save calibration, and then that data is populated, and then you go to save sets to device. That saves it to the device, writes it into the configuration on the Arduino, on the MMJoy. I click it again to make sure it's blue, and now you can see value process. So this is the values that are actually passed to Windows, and you can see that it goes to max, it goes to minimum on X, minimum, maximum. And if we go to window joysticks, drag it over here, go to properties, we can see our stick is moving. Yep. Now it's a little bit jumpy because the springs are quite heavy, so it's kind of clunky, but with the extension, the amount of spring force that's on this base is fine. It's just I have too many, so like if I actually pull off this spring, you can feel how much better it is now, like how much lighter it is. But put that spring back on because I need that spring for having the big extension on. Because of course, the longer the extension, the more leverage the stick has, the more spring force that you might need to have it the way you want it. All our buttons are working. Yeah, everything's working. With the micro USB, you want to make sure you get good ones, quality cables for data, because some of them are not that great. And yeah, you can tuck it in there. And then, here, on these two screws, you can put in with long, I think these are M3 by 12. You can just screw in a little strain relief, just to keep it from pulling out. So another consideration for setting up your stick is the length of this extension. Now, it'll vary based on whatever office chair or if you're mounting it in a sim rig. This has an offset, and then the bar comes out along the front, so that if you have a chair that doesn't have a cutout, there's a space for the stick to be able to come back. Now, all of the dimensions of this stuff will depend on your particular configuration, and you're limited in that this bar can't extend up much further without hitting the threads for the grip. So you can loosen this section here and telescope to kind of fine-tune the position so you have just the right height for your grip. Okay, so now that you have your gimbal wired up with the extension and the grip, you can see that it's, well, not really usable as a stick. And that's because we need to have a way of holding it to the ground. So this is an additional set of pieces that is the frame that we can put underneath the gimbal, and with that, we can use an office chair to hold it in place. So this is two 50 centimeter long aluminum extrusions. You can use any length that's appropriate. I just happen to have these pre-cut 50s, so that's what I'm going to use. Then we've got these two pieces that are the wheel chocks that the office chair wheel will go into. We have felt pads that just go 22 millimeter felt pads. And then we have these two cross pieces that also have felt pads. In order to mount to the base, we have these holes that are down here, and those take M6 by 12, and you can get for V-slot, these are M6. They have a little bearing in them. There you go. Got it there. We'll need two M6 bolts. Run them through. Now, on the side with the PCB, because the corner of the PCB is going to be in the way, you can use one of the other holes. So here I'm going to use this center hole for attaching it. Slide that down. I can get that one in there. And line up the last one. Now they're not fully tight. I get these square to each other. And then we can use this on the end, like that. I need to make sure the nuts are lined up so they go in the groove. There we go. Now you tighten these guys. I'm going to leave these loose for now. And I attach that. I'll put these guys both on the other end. The reason why I'm leaving these loose is because I want to make sure that these go on straight. Right? By having these on here, it'll make sure that these are parallel. Now, these pieces, keep it nice and straight. Now that we have these guys on, we use an Allen key just to tighten these in position. It's locked in place. Make sure that they're straight so that when they lock, they have enough space to rotate. And we want this facing to the back. Alright. Don't tighten these all the way in just yet. We're going to have to adjust them. We'll actually just tighten one of them. I'm just turning the other screws, turning them, make sure the nuts are loose. So I'm gonna get jammed. I'm just gonna eyeball it for now. I'm just gonna tighten this one. Okay. Now, you take our office chair, get your two wheels. Wheels on there. The other wheel on. There you go. Go full back stick, and now you can see it's hitting at full back stick, which means just trying to find a good balance. That the stick can go all the way back. Alright? Okay. Now, if I sit in my chair, my leg over. Now obviously this is too high, but if you imagine your grip's down here, so this extension is too much. Probably need to be 10 centimeters lower, but yeah. Now that's moving a little bit because this isn't screwed in the back. Yeah. Now the weight of your office chair holds the stick onto the floor. Now, yeah, this would be down here. It's held to the floor with these guys. So the weight of the chair, and then in the future, we'll have rudder pedals here, or you can mount something like a piece of wood out here and put pedals on that. Adapter plates could be made by the community. Just by using longer bars, you can mount something there. We can cover up this guy with this piece here. It just takes M4 by 20. It goes in those holes. We just tuck that wire in like that. Make sure that guy's sticking out. There's a little port there. Just kind of tuck it all in. Cover up the cams. It's the same part. Just stick it on there like that. Screw it in. And now it's completely covered. I'm very excited to finally get this update out to the community, and I really look forward to seeing everybody building their gimbals. Please consider subscribing to my Patreon. It is a huge help for the project. All of the materials that are necessary for producing this prototype and getting this far have been graciously paid for by my patrons, and it would be not possible without you guys, especially since my 3D printer kind of just gave up the ghost. But we continue to move forward and keep watching this space. I've got future plans, such as rudder pedals to go with the project that will be a part of the whole office desk wheel chock assembly. I'm also excited for the helicopter edition, which will be available on the Patreon, as well as some future ideas and potentially a Mark III version of the gimbal. And consider subscribing to this YouTube channel so you can get the latest updates as new developments in the project move forward. I'll see you in the sky.